Oxidation-reduction reactions, also known as redox reactions, involve the transfer of electrons. So some vocabulary that you need to know. Half reactions refers to half of the reaction that shows the electrons involved. So the oxidation half reaction involves the one that loses electrons. The reduction half reaction involves the one that gains electrons. The reducing agent donates electrons, thus causing reduction. And the oxidation agent accepts electrons, which causes oxidation. An oxidation number or oxidation state is the number of charges the atom would have in a molecular compound if the electrons were transferred completely. So we follow these 6 rules. If it's a free element, in other words, it's not combined with any other element, then it's 0. If it's fluorine in a compound, fluorine's oxidation number is always -1. If oxygen is in the compound, it's typically a -2. Unless the oxygen is part of a peroxide, then it's a -1. Hydrogen's oxidation number is +1 when it's with nonmetals and -1 when it's with metals. All group 1 metals have a +1 oxidation state. All group 2 metals have a +2 oxidation state, and boron and aluminum both have a +3 oxidation state. If the compound is neutral, then the oxidation number totals have to sum to 0, and if it's a charged compound, then the oxidation number totals have to sum to the charge. So for example, if we have lithium oxide, which would be Li2O. Oxygen's oxidation number would be a -2. Lithium's oxidation number would be +1. For the total, we actually have 2 lithiums, so we would have a total of +2. There's only 1 oxygen, so we can add a -2. So the total equals 0. So these are my oxidation numbers. Nitric acid is HNO3. Oxygen would be a -2. I have 3 of those, so that's like a total of -6. Hydrogen is next to a nonmetal, so it's a +1, and I only have 1 of those. So if I was to add all that together, it would have to equal 0. That means my nitrogen has to have an oxidation number of +5. So these are my oxidation numbers. The dichromate ion, Cr2O7 -2, has a -2 charge. So oxygen would have an oxidation number of -2. I have 7 of those, so that's a -14. To figure out what my chromate is, I have to remember that I have to add it to my oxygen, and it has to equal -2. That means my chromium has to total a +12. I have 2 chromiums, so each one is going to have an oxidation number of +6. So +6 and -2 are my oxidation numbers. There are 5 different types of redox reactions. The first one is the combination reaction, or just a synthesis reaction. The second one is decomposition. The third one is combustion. And then you have displacement reactions, which could be a hydrogen displacement, a metal displacement, or a halogen displacement. For the displacements, you want to be looking at the activity series to tell if the reaction would take place or not. Disproportionation reaction would be the last one. So a combination reaction is when you have 2 or more substances combining to form a single product. So here we have sulfur by itself, so its oxidation number is 0. Oxygen by itself, the oxidation number is 0. When they come into the compound, oxygen's oxidation state is -2. I have 2 of those, so that's like a -4. So my sulfur has a +4 oxidation state. So sulfur 0 going to sulfur +4 would be 1/2 reaction. And then oxygen going to oxygen -2 would be the other half reaction. So my first one, the sulfur, that one has been oxidized, and the oxygen has been reduced. So this sulfur is actually my oxidizing agent, and the oxygen is my reducing agent. a decomposition reaction, you're taking the compound and you're breaking it down into two or more components. So the combination and the decomposition reactions are opposite. Alright, so if we look at the oxidation numbers, oxygen would be -2, potassium in group 1 would be a +1. I have 3 oxygens, so that's like a -6, so that means my chlorine has to be a +5. When they come over here, the chlorine changes to a -1 and the potassium is a +1. Oxygen is all by itself now, so that's 0. So I have K is not changing. The chlorine is changing. So the chlorine is going from +5 down to -1. So that's been reduced. And then my oxygen is going from -2 up to 0. So that has been oxidized. Okay, a combustion reaction involves a substance that reacts with oxygen and usually releases heat and light to produce a flame. It's typically a hydrocarbon, although it could be some other type of compound that's reacting with your oxygen. So oxygen here is by itself, so it's 0. Hydrogen's with a nonmetal, so it's a +1. I have 8 of those, so that's a +8. I have 3 carbons, so that would be 3/8 charge. Over here I have oxygen as a -2, so that's a -4, so oxygen would change to a +4. Oxygen is a -2, hydrogen is a +1. So I have my carbon going from -3/8 to a +4, so it's being oxidized. And then my oxygen is going from 0 down to a -2, so it's being reduced. A displacement reaction, there's 3 different types. The hydrogen displacement. All alkalis and some alkaline earth metals, the most reactive metals, replace hydrogen from water. Most metals will replace hydrogen from acids. So here in our first one we have sodium 0 combining with with water, +1 -2, going to sodium hydroxide, so +1 -2 +1 to 0. So my sodium is being oxidized and my hydrogen is being reduced. In the second example we have zinc 0, hydrochloric acid +1 -1, going to +2 -1 and 0. So my zinc is being oxidized and my hydrogen is being reduced. The metal displacement, you use the activity series and the more reactive metal replaces the less reactive metal in the compound. So I have a -2, it's like a -10, so the vanadium has to be a +5. Calcium by itself is 0, vanadium by itself is 0, -2 and +2. So my vanadium is being reduced and my calcium is being oxidized. Halogen replacement, you have 2 elements in group 17, and the more reactive element in group 17 replaces the less reactive element in group 17. And the order is that fluorine is the most reactive and iodine is the least reactive, so it's actually the order that they're listed in group 17. So chlorine has an oxidation number of 0, potassium would be +1, bromine -1, potassium +1, chlorine -1, and then bromine by itself is 0. So my chlorine is being reduced and my bromine is being oxidized. Finally, the disproportionation reaction, the element is in one oxidation state is both being oxidized and reduced. Hydrogen peroxide is the classic example. Hydrogen is a +1 and oxygen is a -1 when it's a peroxide. But when it's in water, it's a -2. The hydrogen will remain +1. And then oxygen by itself is 0. So here we have oxygen being both reduced and oxidized. Alright, so in these 3 examples, let's figure out what kind of redox reaction is happening and then indicate the changes in oxidation numbers. So our first one would be a decomposition, because we're starting with 1 and breaking it down. Oxygen would start off as a -2, so my nitrogen has to be a +1. And then nitrogen by itself would be 0 and 0. So my nitrogen is being reduced, and my oxygen is being oxidized. In the second example, I'm starting with more than one substance, but ending with one substance. So that would be a synthesis. Lithium by itself is 0, nitrogen by itself is 0. Lithium would be a +1. There's 3 of those, so that's a total of +3, so my nitrogen has to be -3. So my lithium is being oxidized, and my nitrogen is being reduced. In the final one, I have an element plus a compound going to an element plus a compound. So that would be a metal replacement. Both of my elements are metals. Nickel by itself is 0. Nitrogen would be a -2. If I uncross my charges, lead would be a +2. That means the nitrogen has to be a +5. Lead by itself is 0. Uncross my charges, and nickel is a +2. Oxygen is a -2. That means the nitrogen must be a +5. So my nickel is being oxidized, and my lead is being reduced.